Well, let's look now at something you've likely seen before, the atomic theory. And atomic theory deals with the structure of an atom. And when we're talking about the structure of the atom, what we're looking at is the pieces of the atom, those small subatomic particles. And again, these you have probably heard of before. We're going to go over them again. The proton. Now, the proton, as you already know, is a positively charged subatomic particle, and the proton is in the nucleus of the atom, which is the center. Now, the proton is a unique number, so each element has its own unique number of protons. We call this unique number the atomic number for that element. And again, each element has its own number of protons, its own atomic number. Now, the proton is a very, very small particle. So small that its mass is defined a new unit called an AMU, an atomic mass unit. So because the mass is so small, we can't look at it in terms of kilograms or even grams. We have this new unit called an AMU, atomic mass unit, and one proton has the mass of 1 AMU. Now, along with the proton in the nucleus, we also have the neutron. And the neutron is a subatomic particle that doesn't have any charge. It has no charge, or it is a neutral. And again, the neutron itself lives in the nucleus with the proton. Now, protons and neutrons are very similar in terms of where they live, the nucleus, as well as their mass. One neutron is essentially the same as one proton in terms of mass, 1 AMU. Now, if you go on to do higher level chemistry, we'll find out there's a slight variation, but for all intents and purposes, one proton and one neutron have the same mass, which is 1 AMU. And the neutrons and protons together are in the nucleus. Now, if we are looking at that nucleus, and we want to look at the number of protons and neutrons together, this is what's called the mass number. So the number of protons and neutrons added together is what we call the mass number. Now, we're going to refer to mass number, and we're also going to refer to atomic mass. Now, the atomic mass is the average mass of all the atoms of an element. So if we were to take all of the atoms of an element, add them all up, count the number of elements, just like you calculate the average on a quiz or a test, that's what's called the atomic mass. And the atomic mass is also found on the periodic table. We're going to look at that in more detail as we work our way through. So when you are given a mass number, you'll be given it as a dash after an element, like in this case, lithium-7, or just lithium-7. What that refers to is the mass number of lithium, and that number 7 is very important because the number of 7 represents the number of protons and neutrons. Now, if you were looking on your periodic table, you would see that the number of protons in lithium is 3. This means that if we wanted to calculate the number of protons in lithium, we would have to take the mass number 7 and minus 3 to give us a total of 4 neutrons. So 4 plus 3 is equal to 7. Well, the last subatomic particle, the basis for chemistry, is the electron. And the electron is a very, very small negatively charged particle. It is a negatively charged particle. It is 1/1800th the mass of a proton. So it would take 1,800 electrons to equal the mass of one proton. Very, very small particle. Now the electron is unique because the electron is actually outside of the nucleus of the atom. So protons and neutrons in the center, electrons are in the outside, and they're in what are called electron shells. And we'll also refer to that as either orbitals or energy levels, and that's where the electron lives. Now these electron shells, they don't just take an unlimited number of electrons. There's a maximum that can go in each shell. And the maximum number in each shell follows this pattern. 2 in the first shell, 8 in the second, 8 in the third, etc. And the number of electrons in those shells are very, very important when it comes to writing chemical formulas and balancing equations, what we're going to get into further on in the course. Now, what makes an atom unique is an atom contains an equal number of protons and electrons. An atom is a neutral particle. I'm going to say that again. An atom is a neutral particle. Same number of protons and electrons anytime we're talking about an atom. But sometimes the electrons and protons are not the same. When this is the case, this is what's called an ion. An ion forms when the number of electrons changes. So we gain or lose electrons. And this gaining and losing of electrons is very, very important because it's the number of electrons in the outer shell that's going to determine the properties of an element. So we're going to be looking at the details of the outer shell electrons, and they're going to help us determine the properties of an element. Now, when we are trying to draw a picture of an atom is very, very small. So we actually can't see the atom, so we're going to draw pictures called Bohr diagrams. And Bohr diagrams show the electron arrangement around the nucleus of the atom. It's all about the location of the electrons. And Bohr diagrams are very, very straightforward. They actually follow a 4-step process. We're going to go through the steps and then do an example. The first step is we have to place the atomic number and symbol of the element as a nucleus. So anytime we're drawing a Bohr diagram, we'll need to use our periodic table to find both the symbol and the atomic number of the element. Secondly, we need to start drawing our orbital shells. Now we're going to start with the inner shell and then draw electron pairs around the outside. Once we have a pair of electrons in the first shell, then we continue to fill up the remaining shells with electrons, and we follow that pattern of 2, 8, 8. The important thing about drawing a Bohr diagram is when we put the electrons in after the first shell, we put the electrons in as singles first before pairing them up. And we're going to do an example to explain what that means. That's the important piece, is that the electrons don't go in as pairs unless they are in the inner shell. Every other shell they go in as singles. So let's do an example to show you what we mean. Let's look at oxygen 16. Now remember, this number 16 is the number of protons and neutrons. So if we follow the first step, we need to look at the periodic table to find the symbol for oxygen and the atomic number for oxygen. Now if you look at your periodic table, you will see that the symbol for oxygen is O and the atomic number is 8. Once we have the symbol and the atomic number, then we can start doing our Bohr diagram. Now the first thing we have to do is indicate that oxygen is the nucleus of the atom. So the first ring that you draw is the nucleus. Then we want to draw that inner shell. We're just going to draw a circle in the inner shell just like that. And then we're going to put our electrons in. Now if you look at step 2, we start with the inner shell and we put in a pair of electrons. So I'm just going to do 2 little dots, just like that, to show a pair of electrons. And once we have a pair of electrons in the first shell, now we have to draw another shell until we get up to 8 electrons. We want the same number of protons and electrons. So we have 8 protons, there's the 8 right there, That means we need 8 electrons, and this is where we don't put them in as pairs, we put them in as singles. And we're going to count up to 8. There's already 2 in there, so there's 3. You're just drawing little dots. There's 4. There's 5. There's 6. Now once we're at 6, notice we have 4 unpaired in the outer shell. Now we can start pairing. There's 7, and it doesn't matter which one you pair up. I'll pair this one here. There's 8. And that is the Bohr diagram for oxygen.